All right. Hello, everybody. Let's wait for this to kind of get fired up. Okay, so today we're going to be covering naming organic compounds, or more specifically, hydrocarbons, presented to you by Guide Feeney. So, first, what are hydrocarbons? So hydrocarbons are the most simple group of organic compounds, and just if you're curious, organic compounds are just generally compounds that contain carbon, hydrogen, or carbon-carbon bonds. So here's a example of hydrocarbon, and as you can see, they only contain hydrogen and carbon atoms. So there you go. All right, so step one of how to name hydrocarbons. First, you're going to count the number of carbon atoms in the longest chain or ring, and based off of this number, you're going to determine your stem. So as you can see here, you have a number of carbon atoms with your stems. So the good news is that if you know your original stems from naming molecular compounds, they're all the same except for 1 through 4. So once you memorize meth for 1, eth for 2, prop for 3, and but for 4, then you basically have all the other ones down, except you have to take off like that, the A on the end. So yeah. So for example, ethane here, because you have 2 C's, and then propane because you have 3, and so on and so forth, as you can see. You're probably questioning, why is there anes on the end of these names? Why isn't it just these? Well, that's because based on how the carbons are linked, you determine your suffix. So if you only have single bond between the carbons, then you're going to have that suffix ane, as you saw above. But if you have a double bond between the carbons, then you're going to suffix it with ene instead. And if you have a triple bond between the carbons, then you're going to suffix it with ine. And I'm not entirely sure if that's how you pronounce that, but you can, I guess, do whatever you want as long as you just know like what it is. And then, so basically another rule when it comes to when you have a double bond and triple bond, because it's odd, right? Instead of like having just that normal, nice single strand of carbons, you're going to have some weird funky stuff going on. So you need to know where the weird funky stuff is going on. So in order to do this, you're going to count which carbon the double or triple bond is located, taking the shortest route possible, and then add this number with a dash or hyphen I should say, before the name. So for an example, 1-pentene, you're going to have, again, you count your number of carbons. So in this case, we have 5, so that's why it's pent. But then we have ene, because we have a double bonded carbon here, and the shortest route to take that is from the far left, and you count 1, and then there you go. And then the same thing down here, but instead you're counting from, again, the shortest route to get to this double bonded carbon, which is from the left, 1, 2, so now it's 2-pentene. And just another good example, you're going to have 1-heptene here because, again, you count the number of carbons in your longest ring or just strand or chain, which is 1, 2, 3, 4, 5, 6, 7, which give you hept. And this ene will tell you that there's a triple bond carbon somewhere, and you have to take the shortest route to get to this triple bond carbon, which is from the right. So you count 1, so you put this 1-heptene there. And finally, one more rule. So if you have a hydrocarbon that's linked in a ring instead of a chain like we've been seeing, you're going to prefix that name with cyclo. So as you can see here, these are obviously linked in a ring and not a chain. So it's going to be cycloheptane, and heptane because there are 7 carbons, and ane because there are only single bonds between them. And the cyclo is going to be there because it's, like I said, a ring. You can also see it like this, just like this octagon. You'll know that it's going to be cyclo, and then you're going to count the number of little points, which are your carbons, because that's like the carbon's like the main backbone of your hydrocarbons. That's kind of like what this is going to be representing. And then you can do what you have to do to name it based off of this. And here's just another example. You look at this and you say, hey man, this is a ring, so you have to put cyclo on it. And then it's going to be hex because you have 6 carbons, and then ene because you have a double bonded carbon in there. And I believe that you don't need to put a number based on where it's located when it comes to, the cyclo rings. I think they just kind of override that, 1 hexene, or like the other examples that we saw above, because of the fact that, there's no really like shortest route to take, it's just a giant circle. So here's like another example with the rings, and that'll wrap it up. So I hope you enjoyed, and I hope this helps a little bit, and good luck.